So we're now going to wrap up our coverage at the moment on the Completable Futures framework. And what I wanted to do was talk about some enhancements that have been added to it over time after it was first introduced in Java 8. So we'll see that Java 9 and then later variants added a few more things, but Java 9 provided a number of enhancements to the Java 8 implementation of the Completable Futures framework. And you can read more about these capabilities in the link at the bottom of the page. So one thing that was provided was something called a default executor, which is just a factory method that will be used if you don't specify an executor. And so by default, of course, it defaults to the common fork join pool, but you can override that and get control of it through a hook method. There's also a new method called completeAsync. And this is actually very similar to the complete method that was on a completable future all along, but it allows the completable future to be completed asynchronously using a value given by some supplier that's passed as a parameter. There's also a couple of timeout methods. So one timeout method is used to resolve the completable future exceptionally with a timeout exception unless and until it completes before the specified timeout. So this can be used to bound the amount of time you're willing to wait for an operation to finish asynchronously before you give up and have the framework throw a timeout exception. Actually, a very useful feature. And then the fourth issue we're going to talk about here is kind of a variant of this. It's called completeOnTimeout. And what this does is it says, if an operation hasn't finished within a certain amount of time, then go ahead and give back this default result rather than throwing an exception. So it basically says, after I'm going to wait up to a certain amount of time, and if I don't hear back from you, this is my result. This is my answer at that point. So let's talk about this, and we'll show some examples that demonstrate the use of these timeouts, and they're actually really cool. So this particular example we're going to look at, this case study, is in my EX27 folder in my GitHub repository. And what it does is it asynchronously performs web services within a time bound, within a bounded amount of time. And it's a really kind of a cool example. What it does is it attempts to asynchronously find the best price for a flight. So let's say we want to fly from London to New York City, if people are still flying those routes at the moment. And so what we're going to do is we're going to use the supplyAsync factor method, passing in a method, a Lambda expression that says find best price, London to New York City. So that'll start running in the background. And then we're going to use the default executor, which in this case is the common fork join pool, to do this. Now, in parallel to that, we're going to start another asynchronous computation. And this one is going to asynchronously find the latest exchange rate between pounds and dollars. So again, we call completable future supplyAsync, passing in this Lambda expression. It's going to go and check to see what the current exchange rate is. Now, if that computation to try to find out the current exchange rate takes longer than, in this case, 2 seconds, we're just going to use the default rate. Let's say the default rate is 1.5 or whatever the default was. Maybe you would compute the default based on yesterday's average or whenever you got the last reading of that result. So that's going to be a completeOnTimeout method. And what's going to happen here is we're then going to use the then combine completion stage method, which, as you all recall, will be triggered when both completable futures are done. And what we're going to be doing here, what we're trying to do here is we're trying to convert the price from pounds to dollars. So we have, from dollars to pounds. We want to find what the appropriate cost will be in pounds. And what is going to happen here is if it turns out that it takes more than 2 seconds to get that exchange rate, we're just going to go with the default rate, whatever that might be. The next thing we do is we use another timeout mechanism. This one's called orTimeout. And this says, if this entire process takes more than 3 seconds, give up and throw the timeout exception. So what that's basically saying is if it takes more than 3 seconds to find the best price from London to New York City, then throw the timeout exception. And that's a way to put a bound on the amount of time we're willing to wait for asynchronous computations to finish. We then use the when complete completion stage method, which is really kind of an exception handling method. And what will happen here is this method is always called whether an exception is thrown or not. And if the call comes back with non-exceptions. In other words, if the amount is non-null, then we print out the price in the amount plus the fact where we've converted it to British pounds. So we're going to go ahead and print that results there as a result of converting things. However, if an exception occurred, then we're going to go ahead and print the exception if the timeout has happened. In this case, it'll probably say timed out or something like that. If you run the program, you'll see what happens. It's very clever how it all works. So this is demonstrating timeouts that are provided now with Java 9. Let's also then take a look at using completeAsync to perform big fraction operations. So we're going to use completeAsync in this case to multiply big fractions together. This particular example appears in my EX8 folder, and it was a little bit more complicated to come up with an example for this because, believe it or not, there's almost no documented examples of using completeAsync online anywhere. So I had to come up with one, and I think this is okay. We're going to use a string builder to hold the intermediate results here. And we define a pair of big fractions, F1 and F2. We create an empty completable future, which doesn't have a result yet. And then we go ahead and register an action that appends a string when run, and this will get run in the calling thread. So we take the completable future that we made, which we haven't completed yet, and we add to it something that will say completeAsync result equals. So that's going to be called when we begin to do the completeAsync method on this big fraction. Then we arrange to execute a supplier lambda in the common fork join pool. So now we're going to complete this operation asynchronously. If we just use complete, it would block the calling thread. This will not block the calling thread. Instead, what it's going to do is it's going to go ahead and take this lambda expression and then schedule it to run in a worker thread in the common fork join pool. And you can see what it does is it takes those two big fractions and multiplies them together. And when completeAsync is called, that sets all the wheels in motion. So now that computation goes and runs in the background. And then this will multiply the two big fraction objects together in that worker thread in the common fork join pool. And those computations will then run concurrently to anything else we might have between the point when completeAsync is called and where we go to join to get the results. So eventually we call f.join, and so join will block. We had to block here, so this was okay. This is a legitimate use of join. And when this completes, it'll then go ahead and print the result, or we append the result of all this computation to the string builder, and then we go ahead and display that string builder. And that'll basically say completeAsync result equals, and it'll be the result of performing the computation in a mixed string. So again, it was kind of weird trying to find examples to demonstrate completeAsync. This is a reasonably good one, but it's not a widely used method. The timeout methods we talked about before are much more useful. So that's the end of our discussion of the Java Completable Futures framework. Depending on whether we have time left over at the end of the course, we may look through another case study, which is a really cool image crawler counter that's actually quite a bit like your third programming assignment. But we'll probably also review the third programming assignment solution, which will give you much the same results and information about how to write completable future-based code that's actually doing really cool things. So that's the end of the discussion on completable futures for now.